So, yeah, that was, I'm not gonna say to do that one again.
It's a telephone photo or what?
They were just way too early in the season.
You have to watch that fight. I put two valves in the 45. So you a little bit of water doesn't stay in
Then you need a tripod.
the valves.
I plunked down money for an air compressor 32 years ago when I first bought the house. And so it's been amortized.
Yeah.
It's like $100 now.
You guys don't mind it. I used to have. Now I got it up to 45.
I'm looking into your presentation.
I just had it.
The light switches right here.
Yeah.
Technically, you're right. I mean, I might not put in with one of those machines and drag it. That's much right. And it's supposed to be a valve at the end. So you can put water over it. Yeah, that's a good.
Yeah, well.
It's a time of the year, man. You never know. Well, it's either 70 degrees.
Some of them are really nice.
Well, in this yes.
So we had a record warm September, and now October is making up for it.
Yeah.
Oh, this is just crazy. I miss normal.
I don't know if we'll ever have normal.
Yeah, there is no normal.
Alice had that extra large tornado.
Well, October is actually the worst fire season. All the big fires that I experienced were
All the vegetation's
yes. We're going to be we're broadcasting.
I think they will turn it on.
This works out a lot better doing it like this for me. Okay?
And then what did you do? You know what? You didn't do the license, but you gotta use it. I can't believe that we're gonna do this.
Let me know
So
when
we
you
like. That's exactly what we need. Ah, that's right.
Good luck with that.
Not really.
This isn't.
Oh, yeah, there you go. Yep.
Oh, wait, I mean.
Yes, you're right.
I'm not sure I
You ready? Let me go check.
We're gonna go ahead and start.
So every.
That usually means to start being quiet.
How's everybody doing? Right, welcome to our the Colorado Springs Astronomical Society's October meeting. My name is Matt Russell. I am going to be your MC this evening. I'm the president of the club. Just wanted to go over a couple things with you with our schedule here. To begin with, tonight we have a featured speaker, Zach Berta Thompson. I'm not sure where he went. Oh, there he is right there. He is from University of Colorado in Boulder. And he has a presentation titled Sunset on Alien Worlds. Is that correct? Yeah. Right on. I think we're going to be talking about some exoplanet stuff. Good stuff there. After his presentation, we will be doing some observing reports. If you have anything that you would like to say about anything that you've observed over the last couple of months, or if you have a photo to share, make sure that those photos are all given to our guys right here running the computers. We'll take a break depending on time, depending on how overdue or extended we've become. We'll take a break. We'll determine the time of that break at that time. First, I have to say something about timing. Whoever at the Space Foundation finally put a new battery in that clock, they need a raise. Because it's been like 3 months that's been out. So that's great news. It helps me stay on track a little bit more. After the break, I don't see Dave Warner here, so I don't believe we will be doing any outreach reports. Vince Villa, right there, we'll be talking about what's up in the night sky. We're going to be looking forward in the sky for the next month or so. It's October, quarterly treasurer report. And then we'll go into the committee reports, Star Stare, Starry Meadows Committee, long-term planning, and social there. And then after that, we'll adjourn. So that's kind of the agenda for this evening. Hopefully we'll be out of here around 8:30 or so. Last couple of months have gone a little bit longer than that, but that's why we have that padding in our schedule so that we can proceed if we need to. I'd like to introduce the executive committee. Again, my name is Matt Russell, president. Our vice president is Doug Cook. Our treasurer and one of our trustees is Scott Donnell. Our secretary is Vicki Kitzman. Tom Mulliken, our member at large. George White, our social director. And the other trustee is Mr. Bruce Bookout right there. Great. George, you want to go ahead and Next one I'd like to do is, are there any visitors in the audience today? Zach, we'll introduce you in a minute, okay? But what I'd like to do is, if you wouldn't mind, introduce yourself. Let us know how you found us, what your interest in astronomy is, and what you are trying to do with your hobby. So, go ahead.
So my name's Jody. I actually work for the Space Foundation. So I found out about the meeting and thought it sounded pretty interesting and that I would come and see what it's all about. I mean, what's not to love about space and stars? So just thought it'd be neat to see what you guys have to offer.
Jody, did you change the battery in the ball?
I did not, but I will.
I was going to say, we're going to give you a round of applause if you did.
Yes.
Okay.
My name's Willie. Yeah, my wife's the one that actually found out about this.
Good for you.
I was interested because I wanted to start stargazing when we go camping, and I thought that would be a fun opportunity. And I just thought this would be a cool, addition to that.
Right on. Great, thanks for coming.
So,
Is there anybody else? Perfect. Well, for those of you who don't know, we have a mutual agreement with the Space Foundation where we provide some things for them. They provide some stuff for us. For example, they provide this meeting room to us monthly free of charge, as well as our board meetings as well. And another thing that we want to do is I'm going to introduce Kevin right here. He's a representative of the Space Foundation, and he's going to give a brief synopsis of what the Space Foundation does in case you don't already know.
Excellent. Thanks, Matt. Appreciate it. Good evening, folks. My name is Kevin O'Rangers. For those of you that speak French, it's Oranger. Where I grew up in Philadelphia, Camden, New Jersey area, I couldn't get away with that, so it quickly became O'Rangers. So I am the newly minted executive director for the Space Foundation Discovery Center. Again, I want to welcome each and every one of you. I know a lot of you have been here before. Perhaps some of you, this is your first time. Please don't make it your last. And as Matt said, we have been very, very privileged as the Space Foundation Discovery Center to working very closely with you all. And to that capacity, we have been working together on providing space, but not just space, opening up space to our visitors. And as part of that, you all participate with us for our family star parties, and that will continue. Under my direction as the executive director of the Space Foundation Discovery Center, programming is what we are about as an organization. And to that end, 2020 will bring some really exciting opportunities for the Discovery Center. We will be expanding, capitalizing on what we call Space After Dark. So for those of you that like to one interesting night about topics related to space, space awareness, space technology, and everything that is cool with space, that's what Space After Dark will be. So do look for that coming up in 2020. Additionally, there are several members out here of you all that are also the Space Foundation Discovery Center's volunteers. And we are absolutely delighted that they are a part of our volunteer corps. So I would ask those folks that are a part of all you, that are also the Space Foundation Discovery Center's volunteers, would you please stand up and be recognized for your service? Thank you. These folks, again, allow us to do what we do every single day with the general public. So, should you have a spare day or two? Should you have a spare few hours and you'd like to volunteer your time to talk about everything that is cool with space, with kids from literally across the Front Range and beyond, as well as with all of our guests that are here local, as well as tourists from, again, all over the globe, we'd love to have you. If you're interested in volunteering, just check us out at discoverspace.org. Click on the volunteer section, and yours truly will be knocking on your door. We'd love to have your experience, your input, and of course, your time. With that, again, I want to thank Matt. Matt and I are going to be discussing quite a bit about upcoming family star parties and other opportunities for the Space Foundation and the Discovery Center. And to that end, I want to thank all of you for coming out tonight. Again, please don't be strangers. Should you need anything, should you want anything, come looking for me. Once again, my name's Kevin O'Rangers. So thanks very much. Enjoy your evening.
Real quickly, before we introduce our speaker, I want to go over a date. December 7th, Saturday, December 7th, is our holiday party. here at the Space Foundation in Area 51. If you haven't attended that, it's a wonderful event. We had, I think, a record turnout last year, close to 70 individuals. There will be an email going out within the next, probably, I would say sometime in November, beginning of November, to register for that. We have to get a kind of a head count for that. Last month, we talked a little bit. I know that Fred Goodman did a presentation regarding some of the telescopes that our club has acquired over the years. And I am proud to announce that we have gotten rid of several of those, I think 5 or 6 altogether, maybe more. I think it brought in around $800 for the club. So that's good news for stuff that we're not using, and that's great. There is some remaining stuff left over. They probably will go back on the forums at the end of next month, so the beginning of December, and I'll probably talk about that again at our December meeting, or excuse me, our November meeting, just so you can see what's out there and what the price is for them that we want for them. They're going dirt cheap. So keep that in mind. Finally, Fred, I thought you said that you were bringing free beer for everybody today. Where is the cooler?
It's at the same place my flat tire has been taken care of.
All right. Well, without further ado, Doug, would you like to introduce our speaker?
Our speaker is Zach Thompson. He's an assistant professor of astrophysical and planetary sciences at the University of Colorado Boulder. He uses small telescopes to search for new exoplanets and large telescopes to study their atmospheres. He likes to knit. I'm sure we'd all like to hear more about that.
Sure.
This presentation is Sunset on Alien Worlds.
Awesome. Sounds good. All right, cool. Ooh, yeah, could I just ask you to hit go, or should I can also, if you turn the laptop around, press buttons. If I'm not going to break it. Cool. All right, perfect. So the question that I'm not going to tell you anything about today is do other planets out there have life? This is like one of the big questions, one of the things that kind of got me into astronomy in the first place. And it's a hard question, right? Like these are like sort of alien looking actual microbes from Earth. But we could start to imagine, is there, if we think about all of the worlds that are out there, are there on any of those planets, is there life of any kind, whether intelligent life that we could communicate with, or maybe much more likely photosynthetic life that exists that we might be able to sense somehow? And so I'm not going to answer this question today because we don't know, but I want to try to introduce the concepts that a lot of us are thinking about in the quest towards answering this question, and the kinds of approach we might be able to take to get at it. So to start out, let's see. Fingers crossed that this will do something. What? All right, cool. We'll see what happens. So of course, our Milky Way galaxy contains billions of stars, right? Like when you go out and you have your wonderful star parties, with your naked eyes, you can see maybe a few thousand stars in the sky in a really dark sight. That's just the brightest of the ones that are out there. There are billions more that are way too faint for you to see just in our galaxy alone. And then beyond that, there are other galaxies with their own billions of stars. Okay. If we, oh, okay, it does play. Yeah, great. And the stars move across the sky. You've seen that before, or you'll see it when you go camping. Sounds great. Okay. Yeah, let's go ahead. So what I want to talk about today is how do we find planets around those stars, and how do we study planets around those stars? And so the real challenge here is that even if I get up above Earth's atmosphere, if I take the Hubble Space Telescope, arguably the best telescope we have in space right now, point it at the closest star to us, this is Proxima Centauri, you see all of these like complicated things coming from the optics of the Hubble Space Telescope, but none of this is actually like seeing a star, seeing the actual disk of the star. This is just the optics. This is just things being blurred out. It's all just effectively a point of light. And so how on Earth could we see a planet a tiny little thing that is maybe 1/10 billionth as bright as that star sitting somewhere within the closest pixels in this image. That's a really, really hard thing to do. So we actually have to turn to other techniques to be able to do that. And I should also say, like, please feel free to interrupt me here and ask questions. I spend a lot of time lecturing in classes, and I definitely don't know what you're thinking and what you're wondering. So if things don't make sense, please raise your hand or shout at me. Okay. So the technique I want to tell you about actually is pretty old in astronomy. It goes back to, I think it was really developed full steam in the early 20th century by folks like Henrietta Swan-Leavitt. So she's one of my astronomer heroes. You may know her from figuring out the period luminosity relationship in Cepheid variable stars. Ultimately, this is like what allowed us to measure the distances to nearby galaxies and to be able to tell that the universe is expanding. This has now led to several Nobel Prizes, ultimately, right? She's done a lot of really wonderful work here, but all of this relied on making very careful, repeated brightness measurements of stars. So just measuring the brightness of a star very, very carefully. And back in the day, in early 1900s, you would use something like this. This is a photographic plate of the small Magellanic Cloud here. So down in the southern hemisphere, this is one of the closest galaxies to us. You can see lots of handwriting on here pointing at individual stars. And with data like this, an old photographic plate, you could measure the brightness of stars by using a little tool that what they used to call fly spankers, for obvious reasons. It sort of looks like a fly swatter, with little reference stars exposed onto it. And so you could look at this and say, oh, I see a star that, and then in here, this star is about that bright, and do very careful comparisons between them and be able to measure the relative changes in brightness of any particular star. And so this, there's a long legacy of trying to make very precise brightness measurements. Back in the early 1900s, really precise would mean maybe a few percent, which is really impressive to me that you could do that with a photographic plate to get a few percent precision. Now, with digital detectors, we can get much, much more precise measurements. And so we can get down to, even down to 1 part per million. So 0.0001% in some cases. And so with that technique, if we can measure the brightness of a star, or a ball of yarn in this case, as a function of time, if there is a planet orbiting around it that happens to pass in front of that star, you'll see a little dip in the brightness of that star. Even if this is totally unresolved, you're seeing this from so far away that you don't get to see this actual picture, so I can pretend that it's anything I want it to be. You could still tell that the planet's there by measuring this dip, right? And a bigger planet is going to block a larger fraction of its star's light, and so you would see a bigger dip here. So you can tell there's a planet there, and you can also tell how big that planet is. And you can actually also tell how long it takes that planet to orbit around its star, because you just wait and you see one dip, and then maybe days or weeks or years later, you see another dip, and that tells you the orbital period of the planet around its star. Does that general concept make sense to folks? Okay, cool. We're going to talk about a lot of transits. All right, cool. So maybe a more quantitative example of that is this little simulated image right here, where there's a star in the middle that happens to be orbited by an impossibly big planet, a planet that is the same size as the star itself. So when that planet goes in front of the star, the brightness of that star drops down to 0% of its usual value and goes back up again. And you can actually see this star winking out of existence for a moment inside this little movie here. But the same technique applies if we put a much smaller planet around that star, and now you definitely can't see it in the movie, but with a precise enough telescope, you can still measure this nice little measurement of here, this planet blocks about 1/3% of the star's light. All right, so with like those concepts that we've talked about, we can actually introduce a whole bunch of planets that we don't have in our own solar system. If we start from the 8 that you're all pretty familiar with, Pluto, if you want to include Pluto. I don't know. I don't care. Whatever. Call it whatever you want. Yeah, it's still fascinating, whatever its name is. So if I take the 8 big planets in our solar system, I can put them on a plot that looks like this. So down here I have planet mass and planet radius. So big planets, like very massive planets like Jupiter and Saturn, are about 10 Earth radii. Down here is Earth at 1 Earth radius and 1 Earth mass. And I have some models on here saying that if I have a ball of rock of a given size, that does a pretty good job of matching the mass and radius of Mercury, Mars, Venus, and Earth. Does a terrible job of matching the radius of Jupiter and Saturn. These are giant balls of hydrogen and helium gas. And then Uranus and Neptune are somewhere kind of in between. Okay? And then if I look at this axis now shows the amount of heat that planets receive from the sun. So over here, in true astronomer fashion, I put the big numbers on the left just to screw with you. No, because over on the left, this is like really close into your star, and then over on the right is really far away from your star. And so there are, like on here, 1 corresponds to the amount of heat that Earth receives from the sun. And so if Earth receives a little bit more, then it's too hot to have liquid water on its surface. And if it receives much less than this amount, then it's too cold to have liquid water on its surface. It has frozen water on its surface. And so this blue band here is what we sometimes call the habitable zone. It's probably better to call it like the distance away from a star where it's not bonkers to imagine there being liquid water at the surface, but we say habitable zone for because that's something that we would think about when we're looking for life on another planet. Is there liquid water there, right? And then the gas giants are really far away. Okay, so that's our like, yeah.
So how many million miles is that band?
How many million miles is this band?
Like, is it plus or minus 10 million miles from our Earth?
Sure. So Earth is, I think, in astronomical units. So like 1 is Earth's distance away from the sun. So 93 million miles. And this band goes from just inside maybe 0.9 out to 1.4, 1.5 astronomical units. So yeah, so it's a few tens of millions of miles here, I guess you could say. So it's relatively broad, but we don't quite, like, you'll notice on this plot, Mars is in the habitable zone. I would not particularly call Mars a habitable planet right now. It's pretty cold and pretty dry. But you could imagine if I made Mars much bigger, maybe it would have been able to hang on to more water. Maybe it would have a larger greenhouse effect. Maybe it would still be covered with plants today. Who knows? So this is a very fuzzily defined region. Okay. So now let me add all of the planets that we know of. And these are all detected through that technique where we have measured a dip of that planet passing in front of its star. So we know how big it is on here. We've measured its orbital period, so that allows us to figure out how far away it is from its star and therefore how much heat it receives. And then down here, we can actually also figure out the mass of the planet by seeing how much the star wobbles in response to the planet orbiting around it. And so on here, you see broadly similar trends, like planets that are similar in mass to the Earth tend to be rocky, like the Earth. And then they get bigger and bigger and bigger, and then you have a bunch of gas giants up here that are like Jupiter and Saturn in a lot of ways. They're like Jupiter and Saturn in a lot of ways. They are not like them in another way, which is that many of the giant planets that we know of orbit so close to their stars that they are heated, so they receive 10,000 times as much energy as Earth receives from the sun. So the temperature of these is a few thousand degrees in Celsius, Fahrenheit, Kelvin, whatever you want to call it. These are really, really hot planets. They're like, they are wacky things. I could go on about these for hours. But then we also have this population of there are a lot of planets on here that are intermediate in size between Uranus and Neptune and Earth and Venus. We don't have any of those in our solar system, so that's kind of fun. There's this enormous population of planets that exist out there. We actually know that on average, stars have at least one of these kinds of planets that we just don't have a single one of in our own solar system. And then down here, so I also want to highlight on here, these are the planets that we have found. This is not a good representation of like, if I go out and scoop up all of the nearby stars, what planets actually exist around them. We're missing planets down here, not because they don't exist, but just because they're really hard to find. That if I wanted to see an Earth-like planet around a Sun-like star, I need to detect a dip that is 0.01% deep and happens once every 365 days. It's a hard thing to do, and so we haven't done a particularly good job of finding planets like that are really small or really far away from their stars. Okay. Do folks have questions about this?
One question.
Yeah.
What is the rough percentage of the planets that you found that you believe to be rocky iron core sorts of planets relative to the gas giants?
Of planets that we have found, a relatively small fraction. If we correct for all the biases and the fact that the big ones are way easier to find and the small ones are much harder to find, these kinds of planets, you have them around about 1% of stars has a planet like this, a hot Jupiter. Planets like this that are roughly Earth size and sort of, somewhere in this range, approximately 100% of stars have them. So these are at least 100 times more abundant than the really close-in Jupiter-sized planets. Yeah.
Yeah. So these are all being detected by luminosity differentiation.
All being detected by just a tiny dip in the brightness of a star.
How do you differentiate between exoplanets and binary stars?
Oh, so on here, so a binary star on here would be off the charts. So a binary star on here might be 100 Earth radii. It would be 10 Jupiter radii. So it would be way up there.
Some binary.
Yeah. But there are some stars that are similar in size to Jupiter-sized planets. So at some point, my glib statement there gets a little bit fuzzy, and it requires a lot of work to figure out whether it's a star or a planet. But yeah.
I'm familiar with this technique. It's been used for 10, 15 years now.
20, almost to the day.
20 years.
20 in 1 month.
Quite a long time.
Yes.
So do you know what the statistical or the probabilities are that when you're looking at stars, that the ecliptic of that particular star is lined up with Earth, so that you can actually see a transit in the first place? But do you know what those statistics are?
Yeah, so this looks like a lot of planets, but the fact that we have found this many planets tells us that there are many more planets out there, because most planets won't happen to be randomly lined up so that the planet actually passes in front of the star and blocks some of its light. All of the stars out there, their planetary systems are in arbitrary orientations. They're totally randomly oriented. So most of the time you'll have a planet that's orbiting, maybe something like this, and it won't pass in front of its star at all. For close-in planets, about 10% of planets at this sort of distance will actually transit in front of their star. Out here, it's like about 1 out of 200 planets actually transit their star around a sun-like star. Yeah.
Okay, just to expand on Jim's question, check me on this one. I would think that the way you could distinguish between exoplanet and binary star is it would be if it's a binary system, you're going to see a change in the spectral features. As like one of them goes around the other, because they're probably different spectral types. You wouldn't get that with an exoplanet. Does that seem reasonable?
Yeah. That's definitely a technique that we use. Yeah.
Does that also correlate, and Scott, you can talk about this, in dealing with, instead of binary stars, back down to the size of planets, how do you filter out or have algorithms to minimize anomalies? In other words, atmospherics or anything else that could cause a shift in brightness, and yet make sure that you're actually looking at what a planet did rather than something else.
Right. It gets really tricky. And so there are, maybe I'll come back and talk to you later about a lot of the details here. But yes, long and short of it is we have to do a lot of work to make sure that the dips that we're seeing are actually caused by planets and not by Earth's atmosphere, a wobble in our telescope pointing, or the star behind the planet itself, or something else even. But yeah, okay.
Of all the methodologies, you're focusing here on transiting exoplanets.
Yes.
Do the other techniques provide the same level of data, or is it different data sets that are not necessarily applicable to the field, the numbers you're presenting here?
Yeah, so I'm definitely focusing on just planets that pass in front of their star. That's because I'm really keen to talk about the radii of planets, of how big they are, and this is really the only way that we have to measure those. There are, and I want to talk about how we can use this to study their atmosphere. So I'll dive into that, and then I'll come back and answer some more questions here. But there are some of those other methods where you're like actually directly imaging a point of light next to its star with a really fancy adaptive optics, allow you to find planets that are like way out here on this plot, which is really like a whole fascinating other story that you should invite somebody else to come tell you about.
Go find us another exoplanet.
Yeah, exactly. Yeah, all right. So I just wanted to emphasize the point that despite what things look like on that plot, small planets, so this is a plot showing size of planet and then how many planets are there per star with a period interior to the orbit of Mercury. So we have 0 planets interior to Mercury's orbit in our own solar system. If you add things up here, you get to about 50% of stars has a planet larger than Earth interior to the orbit of Mercury, which is a kind of cool, wacky thing to think about. Okay, so part of the main reason I want to talk about these transiting planets here, the ones that pass in front of their star, is that we can use these to study the atmospheres of planets and learn really cool things about them. So I want to walk through what this experiment looks like. And this is where the title of my talk comes from, why I wanted to talk about sunset on alien worlds here. So to start with this, I want to start with like a little circle to represent our sun. And this is the sun as seen from outer space, where if we measure how much blue light, how much green light, how much red light is it putting out, it's roughly equal amounts, right? So I could make a very boring plot here that says this is a white star that is emitting white light, where everything blends together and makes white light. If I put that star behind Earth's atmosphere, so now here we're going to watch this star as it travels downwards and sets at sunset and see the color and how these numbers here of the relative brightness of different wavelengths changes. What? All right, so as it goes down, Earth's atmosphere is really good at scattering blue light, so we lose a lot of blue light there. And like right before the sun is about to set, it looks this nice, beautiful reddish glow because all of the blue light has been scattered away from our atmosphere. Okay? And so that statement that the blue light has been scattered away from our atmosphere can connect back to thinking about transits and how much light a planet blocks here. So this is a picture of Earth from the International Space Station, where you can actually see the thickness of Earth's atmosphere here, right? So when we're talking about a planet passing in front of its star, and I said that a bigger planet is going to block a larger fraction of its star's light, the atmosphere counts towards the total size of the planet. So here, if I observe Earth at blue wavelengths of light, it actually appears a little bit bigger than when I observe it at red wavelengths of light. Light is making it through the atmosphere, but all the blue light is getting scattered away from my line of sight. So I have a way that I can quantify how much light of different wavelengths is passing through an atmosphere. So this allows me to do spectroscopy. It allows me to think about, what sorts of chemical interactions in an atmosphere will absorb or scatter light of different wavelengths. Here, this is the fact that Earth's atmosphere scatters a lot of blue light as a reflection of Rayleigh scattering in our atmosphere. We have a lot of nitrogen here. But we can apply this to other planets. So in particular, we could go to one of those hot Jupiters, those Jupiter-sized planets that are heated to thousands of degrees, and watch what happens on those planets as we watch their sunset. And here, first of all, the sun is like 100 times bigger in area because you're so close to it. But as it sets, here, sunset on a hot Jupiter actually turns a bright blue, which is so cool to me. That you could have a bright, if you could withstand the fire all around you on this thousands of Kelvin planet, you would get to see a blue sunset, right? And so we can look at this actually in more detail too. Let's please play the movie. You can do it. Okay, cool. So in here, I think this is going to loop, so we get to see it again. Cool. So we don't have to just measure how much light the planet blocks in 3 colors, right? We can measure it in lots of different wavelengths of light. So it's not just blue, green, red. We can say how much light is transmitted at 700 nanometers, at 650 nanometers, at 600 nanometers, at 550, and any gradation within there. And so if you were to look at this planet, I actually like thinking about Geordi LaForge from Star Trek, right? His visor is in one episode, they talked about how it's actually a spectrograph. And he can measure the brightness of light at millions of different wavelengths all at once. So if Geordi LaForge looks at a sunset on this hot Jupiter, he sees something like this. Where here you can tell that this absorption at 590 nanometers is caused by neutral sodium in the planet's atmosphere. That's what gives you this bluish green color here. And that's because of the extreme temperatures in the hydrogen-dominated atmosphere. It's really, really cool. Okay. So you can learn something about the composition of this atmosphere just by studying its sunset. I'll skip past these. There's some hot Jupiters. Some look like Earth, some look more greenish, but I think we got the general picture there. So I want to take a moment to talk about why this is such a cool idea. Why haven't we observed all of our exoplanets with this method? Why haven't we measured a sunset for everything? And the reason for that is that most of the planets that we know of, most of the plot came from the Kepler Space Telescope. So this is a telescope that is 1 meter, has a 1 meter mirror. This is the most precise photometer that was ever built, launched into space. I love this telescope so much. And most of those planets came from Kepler staring at this very tiny patch of the sky, about 0.3% of the sky for 4 years straight, to be able to find planets that are in these really long orbital periods and with these really shallow transits. But with Kepler, most of the planets that Kepler found, no other telescope can even look at them. Just because the telescope you needed to find them was so dang good. We don't have a better telescope to go look at them in more detail and do a sort of follow-up observation to study the color of its sunset. Right? So I want to show the population of all known planets, where I'm kind of zooming out from the Earth at the center here. And so now we're about 30 light years away. There are all the planets that were found. Black is ones not found by Kepler. Blue are planets found by Kepler. It was very good at finding planets. But it was very good at finding planets in only just a few particular patches of the sky. And so those planets tend to be really, really far away. So if they're far away, they're faint, we can't collect a lot of photons from them. It's really hard for us to study them in much more detail. So the kinds of telescopes that we're talking about to study the atmospheres of planets are things like the James Webb Space Telescope, which hasn't even launched yet, but when it does, it'll be awesome. It's 6.5 meters. But if we need that to study the atmosphere of the closest planets to us, then a little bit of distance goes a long way. Like if we put a planet 10 times farther away, we need a 10 times larger telescope to study it. And we are definitely not going to have a 65-meter telescope in space anytime soon. I would love it, but we won't. So the NASA TESS mission is designed to be the solution to this. So it's a survey to find all of the brightest, closest transiting planets that are out there so that we can do cool follow-up observations to study their atmospheres and things like that. And so here, what's great about TESS is that its telescopes are tiny. Many of you probably have telescopes larger than TESS's. The diameters of the primary lens here is 10 centimeters. They're like glorified camera lenses, right? There are 4 of them all on one spacecraft. And we launched them year and a half ago at this point, and it's working beautifully. It was a day late to launch, so we got to play a bunch of mini golf in Florida. It was fun. For a sense of scale, that like little stamp that I showed you of some pixels going up and down in brightness, that's this little scale here compared to the 24-degree field of view of one of those test cameras, which you might recognize as like a similar scale to Orion. So you have a telescope whose field of view is Orion on the sky. It's really, really, really cool. And the data here are absolutely gorgeous. So this is all 4 of those test cameras. This is actually from the first observing sector. You don't see much happening in here except a little bit of like scattered light from the Earth coming and going. But there are about 10 million stars in these images, and we get a measurement of the brightness of every one of those 10 million stars, including some of the very brightest stars in the sky. And if you zoom in on one of these images, oh, I love this one. Here. Some of the really, please play. Cool. Okay, so you zoom in on some of those images, and this is actually like looking at a difference between each like half-hour exposure and the average of all of the exposures. You see a comet streaking across the field of view, which is a surprise and really delightful to see. But you also see stars like this one right here that are blinking from blue to red and blue to red. So those are all variable stars that are changing. This one's probably changing by a few percent here in its brightness. And then if you look really close, you can see a whole slew of asteroids flying across these images. So we have a month-long movie of the entire sky at half-hour cadence. And I think somebody looked at this recently, and there are at least 1 million asteroids with good light curves that have come from all of the test data so far. It's really, really cool.
Do you know what its limiting magnitude is?
In terms of like we get really crowded because the pixels are 20 arc seconds on a side. But we can see supernova light curves as like a difference in brightness down to about 20th or so. And so we do about 1% photometry in a half an hour on a 16th magnitude star. And we can kind of stack things together.
Tell me someone's data mining this for
Yes.
planetary, wow, this is a huge data field.
Also, there are hundreds of people all over the world working on it. A lot of graduate students. I actually, I have my own little team of, I'll come back to a couple of these plots here, maybe. I have my, come back, I've gone too far. So I definitely had a team of 15 CU undergraduates searching through lots of these light curves and looking for new planets and looking at rotating stars and looking for asteroids and all sorts of things like this. Just as part of like a normal undergraduate class. It's really cool that this is the community that's popped up around TESS data and Kepler data are super supportive. They've made tools that if you learn a bit of Python and with like a couple of lines, you can download the light curve for any star in the sky and make plots from it and start to look for things with it. So yeah, so there's a huge community that's working on it. And a lot of that has been led by graduate students all over. So it's maybe the one who's done the most on this has been Adina Feinstein. She's a grad student at University of Chicago. She's written a tool so that you can go download any section of the test data and make little movies of it and then produce light curves from it and then go search for planets in there. Lots of these tools to make things much easier. So yeah, there is an incredibly rich data set that exists there, both for finding nearby planets whose atmospheres we can study, but also for basically any other astrophysics purpose that you might have in mind. And maybe something I hear that you may have recently acquired a 24-inch telescope by some chance. That kind of a telescope could be really fantastic for actually helping out with some TESS follow-up. So the pixels on TESS are 20 arc seconds on the side. They're really big on the sky. With a basically any ground-based telescope with decent seeing, you can resolve much finer resolution than these individual pixels. And so if there were multiple stars that are contributing to one particular dip that you see in a TESS light curve, you could go back with a telescope on the ground and measure the brightness of stars around here and figure out which star was the one that was actually causing the transit. And so again, there's a great follow-up community that really organizes lots of these efforts so you can contribute to. And so we're doing that from CU. And I have a grad student working on it with the Compress Observatory Global Telescopes. So again, I definitely didn't answer this question of do planets have life, but I've told you that we have a method for studying the atmospheres of planets. And I've told you that we've started to find planets that are kind of like Earth in terms of their size and their brightness. And I've told you there's a survey that has just launched to find the closest examples of all of those planets. So this is still not right around the corner, but we're making progress towards it. And in particular, if we think about what I want to look for in the atmosphere of a planet, would be looking back at an atmosphere that looks like Earth's, where we see a nice, beautiful red sunset, that red sunset caused by lots of blue and UV being scattered away. But if we look at really fine detail, there are some absorption features that we can see when light filters through Earth's atmosphere that are caused by molecular oxygen. And so when we are looking at sunset on Earth, we can see light that travels through space, filters through our atmosphere, picks up the molecular fingerprint of oxygen, travels over our shoulders and goes out the other side of our atmosphere, and then travels onward for many years until maybe it reaches some distant telescope that's looking at us and studying our sunsets. So we could try to do the same thing for the planets that we're finding right now. Right? Okay, I think, oh, and oxygen is exciting because on Earth, right? Like we wouldn't have any oxygen in our atmosphere if not for plants and photosynthetic microbes. So that is possibly one very good indicator that there's life on a planet is if you see oxygen in its atmosphere like ours. I think that's all I wanted to say. And I'll reserve the rest of the time here for answering whatever questions y'all have.
Wow.
Okay.
Yeah, what questions?
So it just occurred to me that when you're looking at a exoplanet transiting in front of a star,
yeah,
the light you're seeing that's being dimmed is all, I want to say it's all sunset light, but that's, I don't know.
It is, yeah, it is. In the same way that when you look at a total eclipse of the moon looks red, right? And the moon looks red because you are seeing light that has filtered through Earth's atmosphere before shining on the moon. That's the only light that's hitting the moon is stuff that has been refracted through Earth's atmosphere. This is basically that light that you could observe on other planets. It's really hard because it's a tiny fraction of the light that's actually blocking the star. Like the planet blocks maybe 1% of the star's light, and then maybe the atmosphere blocks 0.01 or 0.0001% of the star's light. So it turns into a quantitative challenge at some point, but it's basically that light. Yeah.
If somebody was looking at our solar system and they would, they saw, say, Uranus transit our sun,
yeah,
we would have to wait 82 years for the next transit.
Yes.
Are we missing planets because of that?
Yes.
How
Yes.
many percent?
And I would say, yes, we're definitely missing planets because they have really long orbital periods. I would say that we missed out on short period planets because we thought planets should have long orbital periods. So actually, kind of famously, a couple of weeks ago, the Nobel Prize for Physics was announced, and part of that went to Mayor and Caleb for the discovery of the first hot Jupiter exoplanet. and they collected data, and they didn't look at it at first because they thought, well, I'm looking for a Jupiter-like planet. It's going to take me 10 years to collect enough data to see Jupiter orbiting all around the sun. So it was just luck that they were like, oh, well, let's see if there's anything in there. And they found a planet that's orbiting in a 3.5-day orbital period. And it was super surprising, and nobody believed it because it was so weird compared to our solar system. So yes, there are things we are definitely still missing, and we're aware of it. But there's also, I think, that bias of what we thought we were looking for was a hit too. Yeah.
So when you see like organizations that publish findings on exoplanets, typically they have something sort of like catchy at the beginning, like it rains sunscreen or acid or whatever.
Yeah.
And so like,
rubies from sky.
Yeah. And typically that's because of like, you know, like sometimes there's a particular chemical compound in the atmosphere or certain conditions. So like how much of a leap are those conditions actually from the initial findings?
Some of them not much. So like these slides that I skipped past, right? There are. No, it's not that. It's not exciting enough to make it worthwhile. There are some things that we've definitely seen. So like sodium in an atmosphere, we've definitely seen that. There are other things where we've been able to, we have a pretty good idea that, okay, there are clouds in this atmosphere. Like we can tell for sure there are clouds in this atmosphere. We can't necessarily tell what the clouds are made of. But we can talk to our friends who have developed a lot of expertise with theoretical models of atmospheres. And so they can say, so I would like call up my friend Caroline and I would say, Caroline, what do you think it could be? And she said, well, if it's 500 Kelvin, then that has to be potassium chloride and manganese sulfate. Like there are these things that you kind of fit together in a chemical picture here. And so often those stories are coming from this. We've figured out some of it, but we have also made a little bit of a prediction of what this is. But some of them are pretty things that tend to be like, we know what color it is. That's pretty reliable. We've detected this molecule. That's pretty reliable. There's a comet tail of stuff streaming away from this planet. Those are things that we can pretty directly measure. Things beyond that tend to be a little bit more interpretation. Yeah, good question. Yeah.
Two correlating things about the sunset. One is it possible to get better or poorer data collected as this planet gets closer to the terminus of the star, or is it better towards the center of the star? That's one question. And then correlating that to what's coming up in our own solar system next month and some of the studies that can be done with Mercury transiting.
Yeah, so the first question, is it easier to observe this sunset when the planet's like right in front of in the middle of the star or sort of towards the limb of the star? We actually tend to watch we have to look for a differential measurement here. So we tend to watch before the planet passes in front of its star, and then it crosses onto the star. You see this whole dip at lots of different wavelengths of light, and then you see it leave the star again. So in practice, we smush it up. We need to use all of it all together, and having the whole ensemble makes it much easier to figure out what's seeing here. For the Mercury transit that's coming up, yeah, you could this is Mercury has a very, 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 very tenuous atmosphere of which has a little. It's primarily like sodium that is being blasted off by the solar wind. So you could. Nobody's ever detected it, but I am really curious how far away it is from a thing that we could actually detect. So it's way closer to us, so it should in principle be way easier for us to be able to see. People have done this during Venus transits and been able to like pull out some molecules from the atmosphere of Venus. But just because Mercury's exosphere is so tenuous, we haven't really seen it yet. Yeah.
Can this technique give rough percentages of the composition of exoplanet atmospheres, or is it just it has oxygen or it doesn't?
Yeah, we're getting to the point, and actually JWST is going to be great for this. where particularly for the really gas-rich atmospheres, the hot Jupiter atmospheres, yeah, we'll be able to say that this, there's this much water plus or minus a factor of 10. There's this much water, or this much methane plus or minus a factor of 10. And we're feeling very pleased about that factor of 10. We have a lot of like plus or minus a factor of 100 or 1,000 right now, which there is pretty much like, it's there or it's not. But yeah, we're getting to the place we'll be able to make those relative comparisons. So.
I read that they just discovered a moon going around one of the exoplanets.
There is a candidate moon, Kepler 1625 IB. I can't remember exactly what its name is. I think.
Would that have like a double dip?
Yeah, exactly. So they think they see it in that they see a dip of a planet passing in front of its star, and then they see an extra little dip coming along right after that. It's super controversial right now with lots of people going back and forth as to whether or not it exists. Is it a candidate? Is it not? Should we spend another 40 orbits of Hubble studying it again? I don't know.
So yes, given that this data is looking at a very small patch of the sky, so how far away is the closest exoplanet with an oxygen wavelength? And are the Chinese pointing a radio telescope at it on the back far side of the moon?
The closest transiting exoplanet that is known right now is 6 parsecs away, so about 18 light years. There are probably one or two planets that are closer than that. As to whether or not they have oxygen in their atmospheres, we have no idea. We haven't built a big enough telescope to be able to study that yet. A radio telescope on the back of the moon would be really wonderful for studying all sorts of phenomenon. Mostly the very beginning of the universe and the formation of the first stars, but you could also totally think about it for studying exoplanets as well. Yeah.
When they finally get it built, hopefully, how much data will something like TNT be adding to it, being that it still would be Earth-based, but heck of a lot more than anything else we've done so far.
Yeah. So the question's about the TMT. This is the 30-meter telescope. There's also the Giant Magellan Telescope and the European Extremely Large Telescope. Great names. So this is like the next generation of big telescopes that are being built on Earth. And those will help us. That's actually probably what we need to be able to detect oxygen in an exoplanet's atmosphere. Because if you run through the numbers of how precise of a measurement do I need to be able to make to do this for a transient planet around the closest star in just the right conditions, it works out to be about 1 trillion photons when the planet is in front of its star. And so you need to have a really, really, really big telescope in order to be able to do that. And so for some of these measurements, even though we're looking through Earth's own atmosphere, the fact that we need to have such a big telescope that we have to have it on the ground because we just won't have it in space yet. And there are tricks that you can play of observing at just the right time of year that actually the wavelengths shift out of interference with Earth's own atmosphere, but it'll be tricky. Any other questions? All right. Well, thank you for listening to me talk about
Well, Zach, we want to thank you for coming all the way from Boulder. I know it's not a short trip.
I made it.
But it's been a pleasure having you.
Yeah.
And we'd like to present you with a speaker gift, our very collectible mug, which only goes to speakers.
Oh,
for
all right. Well,
Colorado
sorry,
Springs
everyone.
you may have already seen some around CU Boulder. I don't know, but now you've got your very own.
This is beautiful. Well, thank you so much. This is wonderful.
Zach, just remember, if you misplace that mug, you can always go to Fran Bagenal's desk and steal a couple of them from her. Perfect. She won't get it.
I think she has the largest collection in Boulder.
She has the largest collection in Boulder, right? Okay, moving on. Thank you very much again, Zach. That was wonderful. Do we have any observing reports? Fred.
A couple of things. On the 18th, I was fortunate enough to get out and get a wonderful image of the Iris Nebula. It was a little strange evening, and I won't go into a lot of detail, but I ended up almost having to do lucky imaging because for some reason, when keeping the gain at a reasonable level, the images were too bright. So I had to tone that down and cut it down to 30-second images. And I ended up with almost 80 30-second subs to work with, and it came out okay. Last night was an amazing night. I got up, as I do at my age, to do what nature wants me to do. It happened to be about 20 after 12, and I said, okay, the Orionids are peaking. I'm going to take a look. So I opened the window, took the screen out, put some towels out there to block lights from all the neighbors down below, and there's a bunch of them. And the air was stable. It was a perfect night, and I saw in a 2-hour period there were not a glut. It was just right around Orion, but there was a half a dozen of them, and 2 of them were particularly bright. One of them went from, pardon the way it's pronounced, there's 2 different ways, but Betelgeuse or Betelgeuse or whatever. It went from Betelgeuse to the west for about a second and a half. The tail itself had to be at least 2 or 3 degrees long, and it was bright enough because it was so stable you could actually see some colors in naked eye in the tail. It was just an amazing night. And then I grabbed my binoculars and looked at the Great Orion Nebula, and it was so clear you could see the shape of the cloud, especially when the dust was encroaching on the one side. It was just a beautiful night.
Great. Anybody else?
Yes. Fred just said that because I got up at 4 o'clock this morning while I was working late. I woke up at 4 o'clock this morning. I thought, Ryan's out. So I did drag my skull up. I didn't see any Orions from my house, so I moved it. But yeah, definitely got
Bruce?
Fluorescent fossil beds last Friday. I'd say the majority of the visitors who showed up, not the astronomers there, the visitors themselves reported being able to naked eye see the Andromeda Galaxy. So if you've not done the fluorescent fossil beds, add it to your list. It is a wonderful monthly star party that we're doing to support them. So please do.
Quick comment about the Orionids. They're from Halley's Comet, which I think is really cool. Quite often on meteor showers, I do a 5-minute test to see if we're having a shower. So I did a 5-minute test before midnight up until about 2 a.m. I only saw one, but the amazing thing is how fast they are. They're 66 kilometers a second. They're the fastest known meteors of any meteor shower. And you saw that one for 1.5 seconds. I wonder if it was an Orion.
Considering the radiation point was supposed to be from Betelgeuse.
Okay.
That it
Okay,
right
came from
there,
the radiant.
straight
Okay.
across. It
All
was
right.
just amazing.
The one I saw was faster than a blink of an eye.
See, the others I saw, a couple of them actually came from north to south down, very, very brief, very quick. And there was another one that went across from that radiation point. Those were the 2 brightest ones, so those were definitely Orion.
NASA reported in their all sky cams several days before they'd seen 7 fireballs. So I was hoping for a fireball storm.
So space weather's reported, I think, 30 Orionids yesterday from the all sky cams.
Okay.
Great. Anybody else? All right, we'll take about a 22-minute break, so we'll come back here at 7:55. Oh, wait. Yes? Oh, thank you very much. For those of you who have not signed the attendance sheet, please do. It's in the back of the room. If you're a visitor, it'd be great if you could fill out one of our little postcards so we know how to get a hold of you in the future if we need to. That'd be great. And those are back there as well. Thank you.
And I have name badges for anybody who's ordered them. This is members only, new members. If you're a new member and you don't have a name badge, or if you're an old member, you lost yours.
All right, great. We'll see you back in 25 or 20. Question.
You know, I've got covered. And I'm really force on, and I'm concerned about content coming out on Saturday.
Yeah, me too. I've heard anything either. I'll try texting them later on.
John. All right. Awesome.
Same issue.
What's that?
Need a new badge.
Oh, yeah.
I don't recall, I joined on one, but I don't know if I asked for a badge specifically.
How's it work on the member? I've never had a problem. Never ordered.
Get your hats, get your hats. Get your hats, 2 for 1.
The patches are kind of new. We got those like last year. They're expensive. They cost us $85 a piece. Patches. So that's why we sell them for $6. That sounds like a lot of money.
So what happened to the patches that I had from like Jill, that gave me Matt? Those
are them in the white box. Yeah, they were down at.
I thought you said that you made up some new ones.
Well, no, we just.
So those are the ones that are really strong. You are Scott. I'm Len Wilkinson. I just talked to the guy that handed this out to me and said, I talked to you. I don't have my checkbook with me, but he said I could do it online. I'll run you through it, Greg.
Well, I started and finished.
Yes.
That's kind of what I'm doing, Yes.
Probably his property, but. It's on our website, right? Cool. So that's quite hard. I always like one of those guys.
How big is his slide deck?
I just asked him. Let's go ahead and send it to my Google. Bravo Papa. It's too big. We have the Google Drive for get rid of that. Yeah, that would be easiest to do. He said I could grab the presentation, so apparently he can't email it to Google, so if we draw it, we draw it. See it's Astro jar. Some of those images are really long, right? Sure. Brilliant speech. So we're doing a copy out. 7:55. Ah. And we're going to go into and Brian here given earlier, we're going to do that. We're going to do his image first, then we're going to go down. Two announcements, one announcement, and then we're going to this. Okay, got it? Yep. Right now, I'm That's a more beautiful couple weeks ago, maybe? Previous time I trip.
But I was on this with you, trying to, I haven't been working on it.
We ready? Okay, a couple of quick things here before we go into outreach. Art, you had a question for the membership.
Yeah, I'm looking for a wicket border 90-degree eyepiece adapter for like an SCT or whatever. If any of you have something, I can buy it new, but if someone's got one that they don't want, let me know.
Thank you. Second of all, we forgot to show a photograph that Brian had taken over the last month. So Brian, you want to come up here and share your photograph with everybody? Want me to shut off the light?
Yeah, so this was an effort to do the Andromeda Galaxy, Bruce was talking about. As you can see, kind of the fluorescent fossil beds, but I did this from my backyard, so I kind of cheated and didn't drive all the way out there.
That's beautiful.
It's so large, it takes forever to come up. So,
Wow.
so this was done. It's 8 hours, about 8 hours worth of time with a Hyperstar on a C8. So, yeah, that's, there you go. That's what you can do.
Very impressive.
And you did that at your observatory in Black Forest?
Right, so, yeah, so I basically went to sleep. I just started it up, went to sleep. I think I did it over just one night. So,
Perfect. Beautiful.
there you go, nice job.
Outstanding. Okay, Dave Warner is not here to discuss outreach. However, Bruce is going to give a brief synopsis. So thank you, Bruce.
No worries. A lot of our current programs are running smooth. We're getting thin, of course, because it's getting cold. And not only do we not like standing out in the cold, but it turns out the public doesn't like to do that either. This week, on Saturday, it's a daytime event out for the Haunted Fall Festival. That's out on the El Paso County Fairgrounds in Callahan. A little bit of a drive, but very, very pretty out there. Regretfully, it's over by about 8 p.m., so we're not going to be able to get a lot of good stuff for that. We've also got Space Foundation. Please come to support the Space Foundation. They give us space, which just seems redundant for an astronomy club. And then we're supporting also a sidewalk astronomy at Horizon Middle School moving into November. It's blank. No. Again, that's previous Space Foundation. A few other school items going on. The big event will be the Mercury Transit on the morning of the 11th. There's going to be two groups out there. KRCC is actually going to host a group in the field behind them. And then they're going to try to invite their listening audience. We're not sure how many people that may be. Could be 3 of us, for all we know. But there's also going to be a contingent in Palmer Park. So kind of play the game, coordinate with Dave to help make sure we've got an even scattering between the two. How Bidlike and I will be at KRCC at the bequest of KRCC, because the other aspect of our outreach programs that we do, of course, is looking up in at KRCC. You can find our archive of the old story items in there. Wow, we've got no stories in there.
91.5 on your dog.
Yeah, 91.5 and broadcasting. If you go back to our archive, which basically has covered over more than 3 years now that we've been doing this program, so it's really, really good stuff to do. Go back to the events calendar, please. As you can see, it gets kind of sparse and thin. The next big event, of course, will be Florist and Fossil Beds on the 22nd of November. Expect just one operative word: cold. But it will not be as cold as the January or February ones are always the coldest, but also the most beautiful skies you'll ever see. So, final notes. Any further updates? Keep an eye on this. There may be some additions between now and the next meeting.
Bruce, one last thing regarding florist and fossil beds. You had mentioned last month about the IDA.
Oh,
Darks. You want to give an update on that?
Yes, the International Dark Sky Association has a designation known as a Dark Sky Park. For the Forest Service, this is big. If your park gets that designation, it looks really, really good. We have been spending over about the last year gathering data, building a package. We are in the 95 percentile of completion of this package, and we'll be submitting it very, very soon. Those folks who are on that committee are reviewing it internally within the Park Service there, and then we'll be sending it out. But we're expecting to hear, we're going to submit the package. It's about a 3-month period, and then we'll hear some results from that. I'm hoping to have the superintendent come here with the announcement that they've been designated that. That is a major boost in Astro tourism for this area. So this will help. It turns out there are many, many of these dark sky preserve, dark sky town, dark sky this efforts going on simultaneously around here. I'm hoping to be able to give you an update right after the first of the year of all the various efforts. But because of our support for florist and fossil beds, we are getting contacted as being a point source for expertise in helping that. So stay tuned for more dark information. Hi.
Would you like to also tell them what you told us up there about Woodland Park?
What did I tell you about Woodland Park?
That they're on board with the IDA and Florist and Fossil Beds.
Oh, yeah, well, that entire community around there, around Florissant is supporting. They actually have a letter from the mayor supporting their effort to do that. And apparently, Woodland Park is considering looking into becoming a dark sky community. Besides the fact that Westcliff already is, I've been contacted and trying to work out some other communication with a dark sky preserve group outside of Gardner area and things like that. So it's one of these, it's rolling in fast enough that we just can't keep up. Yay. Yeah.
Cool. All right, great. Thank you very much. Vince, you are up.
You be the man.
Vince, you can flip off the lights when you need it. Good, I'll turn the lights off.
I should be fired from this though, because I forgot the Mercury transit, which is ridiculous. If you haven't seen one, you need to go see this. It's one of the most awesome spectacles, even though it's Mercury and smaller than Venus. This perfect little circle traversing the sun. And of course, the nice backstory for Mercury, right, was that its orbit didn't obey Keplerian physics, and the perihelion was precessing too much. And Einstein fixed that with relativity, so kind of a cool backstory too. All right, so what's up this month? We'll go to the next slide here. I always start with the lunar information. I'm trying to repeat these now because it's actually been a year since I've been doing these what's ups. So I'm going to focus a little bit less on the ones that I've already covered and have a couple of other objects to show, but I will mention kind of like the crowd pleasers, the ones that you should see. I just don't have the pretty pictures to go with those ones. The October's new moon is the 27th, 9:38 p.m. And we should be nicknaming these. And that one I would suggest is maybe the Andromeda new moon because perfect location for Andromeda for dark skies. In November, we've got the 12th of November right after the transit there, 6:34 a.m. So the day later, Beaver full moon or the frost moon, depending on which source you look at. And then the November new moon will be the 26th of November. I believe we're going to have one of these meetings just before that, 8 o'clock in the morning. Maybe we could call that the Horsehead new moon because the Horsehead nebula starts to get nice towards midnight around that time. And just a reminder, we're going to fall back to Mountain Standard Time here, 3rd November, which on the bright side, I think with things getting darker, we're going to end up with more time to observe. In the next slide. So the view of the rising constellations, I always pick just the new moon. There wasn't enough change to go through an entire month's worth, but on new moon, we'll look at sunset, show what kind of things are rising in the east, and then we'll look at south and zenith near midnight. So next slide. This kind of sunset on new moon about a week from now, looking at a lot of the good autumn and even some of the kind of early winter constellations starting to rise at sunset. Go to the next slide here. This is looking south at midnight, same day, about a week from now. Of course, you can see Orion still towards the east here, not having passed meridian. And, kind of the same constellations you saw rising in a great location for viewing. Things in Pegasus are going to show up very well. Things in Taurus are going to show up well. Orion's starting to get nice if you can wait up till midnight and see this, various constellations. Next slide. This is looking up towards zenith. It's kind of similar view, but a few other things that towards the north. Every once in a while, I guess I should look over there. Notice you can still see the summer, constellations beginning to set. It's always kind of strange when you see Cygnus first rise. It looks like it's coming up sideways, but by the time it's setting on us in the autumn, it's actually going head first down into the horizon. Something that you can notice here. Let's go to the next. So I'm going to focus on Pegasus for just a minute. Great square of Pegasus, or the baseball square, is very prominent, fairly easy to see. And if we go to the next slide here, the reason I highlighted that, there's this globe at night, which is like a citizen science effort, which is kind of along those same lines of what Bruce was talking about with night sky and dark preserves and everything. They have us just go out, find a familiar constellation, and count the number of stars inside that constellation. And based on that, you can get a little conversion, tell you what the zenith limiting magnitude of your site is. And they've got data going back 12 years. October's campaign, which is ongoing now, we kind of just missed it, is Pegasus. So they actually tell you, count the number of stars inside the Great Square, which gets more and more difficult as you go out to a place like Starry Meadows, where obviously the bright stars aren't as big as the star charts make them seem. They're a little brighter. And here you're seeing 5.5 magnitude on the left. Some of the suburbs in town might support a sky like that. It's pretty rare that most of us closer into town are going to see anything in Pegasus. And then, Starry Meadows, 7.5 magnitudes. Most people's eyes won't see down to 7.5, but it gives you a nice kind of idea as well. Go to the next slide. Oh, and globeatnight.org is that, and it's like a National Science Foundation funded thing through the National Optical Astronomy Observatory, so it's legitimate science. So I ripped off the lyric from the song, where the days are long or short and the nights are long, when the days are short and the nights are long. So We're, of course, tilted on axis as the Earth goes around, and that's responsible for the seasons. Most people know that. Well, it's also responsible for the changing darkness and night growing longer and longer. Right now, we're a little bit past equinox, and night's starting to get a little longer. On the right there is this image of the sunlit side of the Earth and the dark side of the Earth. And you can see the southern hemisphere starting to get the wider band of daylight and narrow band of nighttime, which means the opposite's going on in the northern hemisphere, and that's only going to get even more pronounced as we get towards solstice. Go to the next slide. This is kind of a visual representation of what that is. This is the ecliptic of looking out of the Earth solar plane, and most of the planets will wander along that arc. And in the summertime, that's very low because we are tilted towards the sun. But if you go to the next slide, this is right now, and it's nice and high. That's pretty nice because the planets are rising pretty fast. And there's a super challenge baked into this that I'll get into in a minute as well. But it gives you an idea of the change of the geometry of the celestial sphere. If we go to the next slide. We got kind of the what's up. I've got some really easy and really nice crowd pleasers. I've got some intermediate, kind of harder to see or maybe appreciate, and I've highlighted those for this one. And then the super challenge I was talking about, the Gang and Shine. So the Gang and Shine, most of you probably heard of this, some of you probably have not. So there's actually dust out in the solar system that is rarefied enough that is reflecting light all the time. And under the right circumstances, it'll reflect back to the Earth, and you'll see a hazy little patch of glowing antipodal from the sun, so directly opposite from the sun. But it's extremely weak. And so you generally want to have weak stellar things nice and high in the air, as we all know. The lower down to the horizon, the worse things get, and you don't tend to see it. One thing that's kind of funny, that ecliptic is going to get better and better as we get towards solstice, but it's also moving further and further towards the Milky Way. So you get this competing thing of it's getting nice and high and easier to see, but it's also getting right in front of the background noise, if you will, of our own Milky Way. So it turns out that right around this time of year, and then time in springtime as well, is a great time to go after this dim, faint stuff. It's nice and high in the clear part of the atmosphere, but away from the Milky Way. It's extremely faint. It does move with the night. Sometime an hour or so on either side of midnight, you can kind of see this. It's probably the faintest thing I've ever observed, and I have seen it from Starry Meadows. That or California Nebula, I'm not sure. Some of the easier ones, if you're just setting this up, you want to go camping and check this out, look up the double cluster. There's a prominent constellation, you can even see it from the parking lot here, called Cassiopeia. It looks like a 3 or an M, depending on which way you look at it. And from a dark site, down lower to the right of that M is a little haze patch. And if you look at that, that's 2 clouds of stars being formed. Of course, the Andromeda Galaxy, which we saw that gorgeous picture of, where you can actually see the dust lanes, those Cepheid variables that the presenter was talking about were observed in Andromeda, and that's what made Hubble so famous. Nice background there. There's 2 other loose clusters that are kind of intermediate. I wanted to highlight them. There's clusters littered all over Cassiopeia and that arc of the Milky Way right here, but these ones are kind of nice. So Caroline's Rose cluster and the ET or OWL cluster. If we go to the next slide. Found this image off Wikipedia of the ET or the OWL cluster. A nice little collection, an open cluster, enough there to see that, yeah, these are probably associated stars. Yeah, fairly pretty. If we go to the next slide. Then there's Caroline's Rose cluster. You know, in this area of the sky, it's kind of a shame because there's so many of these. In its own right, that alone would have been a gorgeous, go-to object. But well, I wager some of us haven't even seen this because it's not one of the more prominent ones, which is a shame because it turns out to be very old. If you'll notice, it's kind of orangish reddish because all the blue stuff that now died off, they've burned so fast. And this is estimated to be like 1 billion years old or something. Nice little target, very close to Cassiopeia, easy to track down, moderate sized telescope even in our backyards, and reasonable suburban skies is going to show this fairly well. Go to the next slide. Messier's comets and planets. Lots of Messier still up there. The comets, not so good. There was hope that this Comet C 2018 W2 Africana was going to get bright It did briefly get up to above 10th magnitude, but reports were conflicting, and now it's definitely fading to less than 10th magnitude. Does it? So it's not going to repeat. This 2017 T2 Pan-STARRS was hopefully going to get very bright as well, but it's starting to look like that one's going to kind of fizzle out for us. Orionids, as we said, the zenith hourly rate generally 15 to 20 from dark skies, 40 some odd miles per second, like Doug said. The peak is right around now, actually, but the moon is kind of illuminated right now. It's not a bad show to go try to check out. The Leonids, unfortunately, are going to be washed out by a gibbous moon, and there weren't too many other good meteor showers to talk about in the upcoming month. Jupiter is not still the best. That's a typo. I removed it from this up. Jupiter is too far in the soup if you can see it at all. Saturn is okay, but setting around 9. And so it's starting to get kind of sparse for looking at planets, unless you want to look at some of the further away ones. Neptune and Uranus are okay. And then Venus and Mercury, depending, are going to be in the glare, or starting to get okay for Venus as an evening star. If we go to the next slide. Still a lot of Messiers. The Ring Nebula over there in the setting summer areas. So early in, you can get all of the summer Messiers. Still pretty good. Midnight, maybe a little before midnight now. You've got stuff in Cygnus and the early autumn stars, and then kind of towards dawn, you're starting to get some of these more autumn and winter Messiers. And that's just a sampling of them. If you Google these, they'll give you star charts and everything. Just Messier, because M brings up who knows what machine guns half the time. With that, that's what's up.
Great, thank you. All right, as I said at the beginning of the meeting, it's time for our quarterly treasurer's report. So Scott, would you like to take the floor?
Very good. So this treasurer's report is brought to you by the fine folks at CS Astro that have hats and patches that are available. You can skip this ad in 15 seconds. That are available for you to purchase after the meeting.
I'm trying to skip the ad. I'm having trouble with the button.
I forgot to enable it, sorry. Hey, I'm not a programmer, man. So, all right, as you all know, I've maintained our finances in two separate budget categories or two separate accounts. One is for CS Astro club operations, where we collect membership dues, things like that. And then the second account is the Starry Meadows RMSS, all the income and expenses related to our Starry Meadows properties. So for CS Astro, in the third quarter of this year, we had a net income of just under $4,000, and we had net expenses of just under $1,300 for a net revenue gain of $2,700. This gain was primarily due to $2,700 in annual and lifetime membership dues, and a $1,250 in donations, largely from the outreach work that Dave and his group do. We get occasionally some donation checks for those. So for all 3 quarters this year so far, our revenues minus expenses is positive $3,720. So far this year, we're $3,700 ahead of our expenses. So good job, Scott. Yeah, I think I'll do this again next year. For our Starry Meadows Rocky Mountain Star Stair, we had a net income of $3,300 in the third quarter, and expenses were a little bit higher, $4,167 for a net revenue loss in the third quarter of $881. Hold on though. This is primarily due to income and expenses, primarily from RMSS that were booked in July, which was part of the third quarter. Primarily, we had almost $1,800, a little bit more than $1,800 for the porta potties, and $600 for pins and blings that didn't get cleared until July. And we also had the $1,500 property insurance. Property and liability insurance. So that's an annual check that's written. So add all those things together and you get a little bit, an expense hit on the expense side. But if you look at all 3 quarters combined, so total 2019, we're only down about $458. And when you think about it, we had $12,000, roughly $400 in expenses largely for the electricity. And what this means is that we essentially paid for all of it, $400 of that, through our RMSS proceeds. So I think we've done a great job there. We also had an additional $654. No, this is wrong. So in addition to the $1,250 in donations, we also had another $11.80 in Amazon Smile donations. So those of you that do the Amazon Smile, thank you. We do get a little bit from that, which is always nice. And so that concludes my report. Any member that would like to see any details on balances, whatever, see me after the meeting. I'd be happy to share it with you.
All right.
Okay, don't forget, hats, patches. Hats are $16. Patches are $6. So if you don't like the hat, but want to have one that looks, you could put this on your own hat. Okay, you could put it on your own motorcycle jacket.
I could, couldn't I? All right, next up, Vince and Tom, do you want to talk, since we ended with the treasurer talking about Rocky Mountain Star Stair, would you guys like to give an update for Star Stair?
Yeah, so I'll just stand here. Rocky Mountain Star Stair, we should be trending on a logo at this point in time. It's been very little feedback. I probably haven't done a good enough job of advertising that, but we're soliciting ideas for the logo, which is Return to the Moon for this Rocky Mountain Star Stair. So the logo's slogan is kind of already decided on. We're looking for artwork there. We've seen a couple of variants. I printed out and then left it working for. So we've seen variants of like Back to the Future style one. We saw one with traditional mountainscape in the background. We had a somewhat lighthearted suggestion, but kind of cool actually with that old first Silent Hill.
Yeah.
And in the moon crashing. Right. Yeah. So. If you've got ideas, though, I'm actively looking for those. We need to hurry up and trend on that because we need to get advertising the message out there so that we can start now for the magazines that are going through their cycles in the future, etc. I'm still looking for volunteers for pretty much anything. I mean, we've got a pretty good handle on the kids' activities between Carol and Dave Warner, and my wife is going to help pitch in there again. But there's everything you think of Rocky Mountain Star Stair, the photography classes, all that kind of stuff. We need to come up with a draft schedule to not pack so much in there, but also to have enough volunteers to cover this thing. And so please email me. We meet right after the land committee at Panera's at 9 o'clock hours. If that's not convenient for you, still let me know and I'll make sure you're on the distributions to get access to all of our planning files, etc.
Okay, great. Just one thing to mention is that we've always had a good number of volunteers for Star Stair, and we have to remember that this is our biggest fundraiser. I mean, we bring in a lot of money for the club this way, and the more volunteers that we can have, the easier it is for everybody, and that equates in the end to more revenue. And I mean, just look what we've been able to do over the last couple of years on that property. With the power, the observatory in there. So if you can volunteer some time, it's good to let us know now. I mean, it doesn't even need to be more than a couple hours. We need someone to sit up at the entryway waving to people as they come in. So just take that into consideration. If you do that, we'd all really appreciate it.
And the email link on the rmss.org website will get a hold of us. So
right. Exactly. Bruce, do you want to mention anything about long-term planning?
Long-term planning committee didn't meet this month because we're kind of in a transit moving forward. We currently have very strong interest from some parties, which I don't have a lot of liberty to go into detail on. They're moving forward with their organizations to get back with us about finding that 24-inch telescope a home. For those people not familiar with that, the Air Force Academy has gifted us a beautiful 24-inch historic telescope that we are in the process of finding a very good home for. This is a slow process at this point in time, but I guarantee once we get past certain levels of hurdles, the club determines who we're going to be running to. We are really going to be bouncing up looking for volunteers. Don't be surprised if you get tagged, not volunteered, tagged to do stuff. That's kind of my style. It's you're being voluntold to do stuff. It's because, folks, you're talented. You're damn talented, and we need that talent, especially for this effort. So don't be surprised if I'm pointing fingers and dragging you along somewhere.
Great, thank you very much. George, do you have anything you want to mention?
Yeah. At the family night here next Wednesday, there's going to be a Colorado author named Jeff Gagne. He and his daughter, who's 7 years old, I believe she is, they write STEM books. And their latest book is called Zach and Zoe Adventures, first one. And their latest book is called Zach and Zoe Go on a Field Trip to Space Foundation, which is kind of cool. And within the pages of that book is one of our own members, Ron Sparkman. Ron also works here now. He's one of the social media guys. And if you read the book, he's in there. They've included him in there as part of the story. So you can see Ron in all his cartoonish glory. It's pretty cool. So anyway, Jeff will be out here for the event next Wednesday. And I told him, you got to bring some books. Get you here, Ron will be here. You just autograph some books. He's like, yeah, great idea. And one of the sub characters in the books is a little robot inside every page. So I said, hey, Ron, why don't you dress up as the robot that's on your page? And Jeff said, yeah, why don't you? So for lucky, we'll have Ron dressed up as this big silver robot. I'm going to make him look foolish. That's my plan. Beyond that, coming up on December 7th, holiday party, holiday party potluck right here in the other room down there. You'll see the email go out probably first week in November asking for how many you're going to bring, who's going to bring what. If you haven't been to one before, we've had it here for the past 3 or 4 years. It's in the Area 51 room in the back. It's fantastic. We do the White Elephant gift exchange. Everybody brings food. It's from 5 till 9 p.m. and it's a really good time. And we usually say that 40, 50 people show up. They decorate the room all Christmassy and such, and it's a good time. So look out for that email. Please respond back if you know you're going to make it, maybe or whatever. Just let me know so we get a good head count, so we know what to tell them. And again, that'll be December 7th. So look forward to it. That's it.
For those of you who don't know, we have a special interest group for folks who are interested in astrophotography, and it meets once or twice a month. Brian, would you like to say a couple words regarding that?
Sure. This last September, we had our September start there. Some of you were there. And we had fantastic skies down on our own property. We also hosted at the same time an Astro Imaging Autumn Spectacular, and it was really, really nice. This coming weekend, we're planning on doing the same thing. It's a little bit different because we didn't expect it to be quite as cold this weekend. So we had 100 people that wanted to come, although 98, I think, said maybe they'll be busy. But anyway, the whole point is, Thursday night, it's supposed to get really cold down there. I guess cold here too. And cloudy, so I figured, well, we'll start Friday. It turns out that Friday and Saturday, it gets up into about 50 during the day and close to freezing or maybe a degree or two under at night, those 2 nights, but it's supposed to be very clear. So at least I will be down there. Dave Carpenter, I know, and whoever else would love to come, we'd love to have you. That's Friday on our property, or Saturday, and probably leaving Sunday morning. The other thing is this coming week, which is the Tuesday, 1 week from tonight, we will have our general Astro Imaging meeting, which I host at my home. And I'll send out a notice probably Sunday when I get back, or Monday. So if you would like to get information about that, please give me your contact information, your email, and your name. Make sure you can read it, and we'll pass that list out to you. Thursday, 2 days following, we have our novice imaging group. A week later.
Thursday and a week later, we had to delay it.
Yes, Thursday, okay, right, and I guess, and it wouldn't work out, so 1 week from this coming Thursday, 2 weeks from this Thursday. We'll be, and it's at Barry's home. I'll have information also on that contact list, just give us that information. And so if you are all interested in wanting to try it, it's a great thing, especially having the novice group, because it doesn't take too much to start at all. You can come up with some beautiful images and be very proud of yourself. So thank you.
Thank you, Brian. Last but not least, Barry, do you have some words you want to say about the property that we own?
Well, land committee's been really busy. We got together in July, right after Stars There. We didn't waste any time. I want to just read off a quick list of the projects we're working on and the priority that we've come up with. The first one is getting power out onto the field area. That could include power for the observatory, power for pads, observing pads, and power possibly for RVs. Now, the number 2 is dust mitigation. We've had a lot of problem with dust down there. We're working on how to mitigate that. And of course, the observing pads, that's been talked about a long time. Heat mitigation in town hall. Any of you have been in there when the sun's out and it's about 90, you really can feel the radiated heat. We've come up with a pretty decent proposal already on that. Looks very promising. And then last but not least is fire trailer. We're very concerned that if we ever got a fire in an RV or a fire on the ground, that we're about 30 minutes from getting support. So we really need something we get out there and get things under control. Matt asked me the other day, well, so how much of this stuff what's your schedule in this time? Well, ideally we want to get all done before our MSS 2020, and we'll see how that goes. A lot of it depends on the pricing and how things come in and support we have from folks as far as helping out. But I think it's definitely feasible to get a lot of this done, if not everything done. But that's basically the priorities. Some of these are really complex, like power to the field and RV power. And there's 2 of them, that and the observing pads. So we're going to have a special evening session of our land committee meeting, and it's going to be held on November 12th at my home. Now, granted, we can't have 50 people show up, but what I'd like to do is I'll get out on the forum, I'll put a request for input, and everybody's, if you're in a tent, if you're in an RV, if you got a Class A, if you're sleeping in your car, whatever it is, we'd like to hear from you about your ideas about what would help you have a better time. And I know just the powers really help people, and I had at least 3 people come up to me and say September Stars There was one of the best events because they just had a good time, a lot of their needs were taken care of, we had a lot of camaraderie. It's one thing I do want to say, I mean, it was a real success. We had a couple 3 food events that different people put on, and Astro photography group was down there, saw a lot of really cool photos that came out of it. And the novice group is amazing. They're just really excited about it. So that makes me excited about it. But if you have comments, I really want to hear from you. It's not like, I don't have time to go to the meetings. Don't worry about it. I'll solicit comments and I'll put my email address. Just shoot me an email, would you? I'd like to hear what you have to say. And I'll bring it up in front of the whole group. I'll put it on the agenda. We can chat about it. We're hoping by, say, January, we'll work with the board. Hopefully we can come back to you and give you some real proposals. What we like to do, this is what it'll cost, and hopefully we go for a vote for financing this. But we've got a really good head of steam. Got a lot done last year. Got to thank all the folks that volunteered and everybody that's on the committees. I mean, it's a huge endeavor. So we'll get back with you later, and I'll try to keep you updated month to month as to where we're at.
It's amazing. It's amazing what's going on down there. I'm just so happy that things are progressing there. It's really something to see. Those are all of our committee updates that we have. One thing that I would like to mention before we close out here is that we also have a before the meeting and after the meeting on nights like tonight, where There's a group that typically gets together at Trinity Brewing Company at what 5 o'clock?
Well,
Five-ish?
some of us started really early today. I started at 4:15. I work about 2 miles from there along Garden of the Gods, so it's easy for me to get there. Typically, I'll be the first one arriving and anchoring a table for ourselves, so.
How many people showed up today? About 10? 10 people showed?
Yeah, good little crowd tonight.
And then we also have an after the meeting that goes on at the Village Inn. I'm not sure how many people are going this
These
evening.
people are wild at the Village Inn, though.
Yeah, we got a.
I may have a brewery problem.
Close
but I don't know.
down.
You guys have a pie problem.
So there's a couple of little social engagements before and after this meeting. So if you want to attend this evening, feel free. That'd be great. Does anybody have anything else for tonight? Okay, meeting adjourned.
Yes.